In this video, we will study about motion graphs part 2. Previous video was related to distance time graph and displacement time graph, and this video is related to velocity time graph. At some point, we will compare velocity time graph with distance time graph also. Beside sketching the graph for various situation, we will also calculate the distance traveled by a body using velocity time graph and the acceleration of the body using velocity time graph. So stay with us. So first we have a review of distance time graph. There are 4 situations shown. This one, body not moving, body moving at constant speed, body accelerating because gradient is changing and gradient is decreasing. First one is stationary, uniform velocity because the gradient is constant, it's a straight line. Acceleration because gradient is increasing, it means body is accelerating, and gradient is decreasing means body is decelerating. So remember all these shapes of the graph, because now we are going to compare this with the velocity time graph. So this first graph is stationary, but when we have velocity on y-axis and time on x-axis, this shape will not be showing stationary state. It will be showing uniform velocity. This one, this, and this. First one parallel to the x-axis or time axis. So this one shows uniform velocity. It means body is in motion, but the velocity of the body or speed of the body is constant. Second one shows uniformly increasing velocity. So this is uniform acceleration. Third one, the acceleration is increasing because gradient is increasing. It means this is non-uniform acceleration. The fourth one is also non-uniform acceleration, but here the acceleration is decreasing. Here it does not mean body is slowing down. It means that body is still speeding up, but the rate at which body is accelerating is decreasing. So in distance time graph, this shape shows body slowing down and coming to rest, because whenever this y-axis, the graph becomes parallel to time axis, distance time graph shows body is not in motion. Time is passing, but distance is not changing. But here the velocity is constant. Body has attained constant velocity. Some more graphs, and they are showing deceleration because velocity is decreasing. First one is uniform deceleration. Velocity is decreasing uniformly. Gradient is constant. And finally, it comes to rest. Second one is also showing the deceleration, but non-uniformly. In the beginning, the rate of decrease in velocity is fast, and then it decreases. And finally, body stops. So rapid, then slow deceleration. The third one, slow, then rapid. It means in the beginning, body was having decrease in speed, but that rate was slow or less. But later on, the gradient increases means the rapid deceleration. Now, the case 1. Here we will plot a graph of a body which first accelerates uniformly and reaches a velocity v. Then goes further with the same velocity v and then decelerates uniformly and stops. So let us see what will be the shape of the body. It accelerates uniformly, means graph is a straight line. Then it goes further, but with the same velocity v for certain time. Then it decelerates and comes to rest. First part, this one, it shows uniform acceleration. This one, uniform velocity. And this shows uniform deceleration. As I said in the beginning, we will compare this shape with the distance time graph. So what will be the shape of distance time graph? Let us see this. Because this is acceleration. So acceleration, it will be having change in gradient. So the gradient is changing. Then it attains a constant velocity for certain time, this region, and then body decelerates and finally comes to rest. So this one, acceleration, this one, uniform velocity, and this one, deceleration. What will be the shape of acceleration time graph? Because the gradient of velocity time graph gives us acceleration. So here this is the constant gradient. So let us see what will be the shape. This. The gradient is constant. So what is taken along y-axis now? Acceleration. And x-axis time. No uniform velocity means no gradient. Gradient is 0. So acceleration is also 0. Then body decelerates. Means the direction of acceleration is opposite to the direction of velocity. So this one. So you can compare the region, uniform acceleration, this part, constant velocity means 0 acceleration, and then negative acceleration. The gradient of velocity time graph tells acceleration. Now here are some more points to remember. Gradient or slope means division. Change in y-axis divided by change in x-axis. Area multiplication. The gradient change in quantity on y-axis. Here we are talking about velocity time graph. So change in y-axis, that is velocity divided by change in time. Area is change in y-axis multiplied by change in x-axis. That is distance is equal to speed into time. S is equal to V into T. So area of velocity time graph tells distance or displacement. Area is multiplication, velocity multiply time, meter per second is the unit of velocity and second is the unit of time. So this second and second get cancelled. So unit is meter. Now case 2. In first case, we just sketched the graph. Here we have the values. So we will be working out the distance. We will be working out the acceleration. So this is the shape of the body. It has the shape of the graph, uniform acceleration, constant velocity, then increasing acceleration, decreasing acceleration, again constant velocity, and then deceleration. So what is the distance covered in first 10 seconds? So what do we do in order to calculate the distance covered in first 10 seconds? Area under the graph is distance. So 10 second comes somewhere here. 4, 6, 8, and 10. So this shape is what? Triangle plus rectangle. What is the area of triangle? Half into base into height. What is the area of rectangle? Length into breadth. This is triangle plus rectangle. So half into base is 4 and height is 10 plus this 10 into 6. Height or length you can take 10 and this is 6. So 4 and 6 means 2, 4, 6. So 20. Answer of this area of triangle is 20 and area of rectangle is 60. So total distance covered in first and second is 80 meter. Now let us calculate acceleration in first 4 seconds. So this is a uniform acceleration. Acceleration is gradient. Delta V, change in y-axis over change in x-axis. Y2 minus y1 over x2 minus x1. So what is y2? 10, y1 0 because graph is passing through origin. 10 minus 0 over 4 minus 0. So answer is 2.5 meter per second square. This is the acceleration during first 4 seconds. Now, calculate the acceleration at t equals to 16 seconds. So where is t equals to 16 seconds? This one. So we have to first, because this is increasing velocity, changing acceleration, non-uniform acceleration. So we will have to draw the tangent at that point. Acceleration is gradient. So this is the time at which we have to find out the acceleration. So draw tangent, which passes through touches the curve at that point where the time is 16 seconds. So we will take, this is x2, y2, x1, y1. Let us solve. Delta V over delta T is equal to, what is y2? 20. And what is y1? 8. x2, 19.5. x1, 12. So acceleration is 1.6 meter per second square. So we always draw tangent at that point when the graph is a curve. Now, acceleration at t equals to 20 seconds. So where is t equals to 20? This. So here the acceleration is decreasing. So tangent is drawn at that point. Let us see what are the values of y2 and y1, x2 and x1, x2, x1, y1 and y2. Let us substitute the values. y2, 25, y1, 19, x2, 23 and x1 is 16. When we solve it, it comes 0.86. See, this acceleration, meter per second square is the unit of acceleration, and this acceleration is less than before, means acceleration is decreasing, but not the velocity. Velocity is still more. Velocity at t equals to 20 second is more than the velocity at t equals to 16 second. You can see this. This is 2.5 velocity at that point. So velocity is different. This is not deceleration. This part is deceleration. So in order to find out the deceleration where the velocity is decreasing and finally body stops. So let us see how to calculate the deceleration. Final velocity 0. Initial velocity 22.5 divided by time is 30. Each block is showing 2 seconds here on x-axis. And this time is 26. So minus 5.6 meter per second square. This is rapid deceleration because this is a bigger value and it takes shorter time to decelerate here. There is big change in velocity in short time. So this part is deceleration and body at 20 second is still accelerating. But this acceleration at 20 second is less than the acceleration at t equals to 16 seconds. Now, the case of bouncing ball. So and this is the velocity time graph. Velocity is a vector quantity. So change in direction is to be considered. And when the one side is taken positive, the other side will be taken negative. Suppose ball falls towards the plate. When ball falls, initially the velocity is 0 and it speeds up and reaches the maximum velocity with which it hits the plate. So this is the shape of the graph. And we have taken downward motion positive. Now ball bounces off. And here we are assuming that there is no loss of energy and it travels same distance after rebounding. So now up is negative. Upward motion is taken negative. So it is on the negative side of the graph. Positive y-axis and negative y-axis. And same acceleration. That is, it is falling under gravity. Now down again and up. How do we find out the height up to which body is moved up or body has fallen? By area under the graph. Area of this first triangle will tell us the distance of one journey, that is from top to bottom. Now, the speed time graph of the same case. The velocity time graph, velocity is a vector quantity, change in direction is to be considered, but speed is a scalar quantity. So we ignore the direction, we only see the magnitude. So in the beginning, the body speeds up when it falls from a height. And when it bounces off, the velocity decreases. Here it is speed. Speed decreases. And at maximum height, the speed becomes 0. Again, it falls, hits the ground with the maximum speed, and then bounces off and stops at the maximum height. So speed vector quantity, scalar quantity, we don't draw the graph on the negative side of the y-axis. Only increase in speed and decrease in speed is shown. And here it shows again the uniform acceleration. Now a ball is thrown vertically upward. X's are drawn for this. This is the ball and the ball is thrown upward. So let us see here up is positive. So what will, and because when the ball was thrown, it had maximum initial velocity and at maximum height it stops. So the initial velocity will be maximum and the final velocity will be 0. This. Now ball returns and hits the ground. Down is negative. So this is the shape of the graph. And area under the graph will tell us the distance moved by ball while going up and while coming down. Because this portion is having smaller triangle, this area is smaller and means the distance which was covered by ball while going up when it was thrown by the bat, this distance was smaller. And when it falls, because it goes to the ground, so this covers more distance while falling. So this area is bigger. So velocity is a vector quantity. So here up was taken positive when the ball went upward. It reached the maximum height, velocity became 0. And when it returned, the down is taken negative in this. And this sign convention is up to us. We could have taken up negative and down positive also. Then in that case, the graph shape would be opposite. Thank you. Allah Hafiz.